Right. Hi, good evening and welcome to the first expert panel of the year. Especially welcome to all of our new joiners. We've had a load of people join over the last week, so hi to you all and anyone who's new to the group. This is the kind of thing that we do on a fairly regular basis. It's very cold outside, so what better time to start talking about heating system efficiencies? And tonight we're going to be talking about optimizing heat pump efficiency and monitoring data thereof. I'm joined by my usual dream team, Richard and Kimbo, and I've got some extra special guests in this week who know all about heat pumps, all about monitoring, and I'm going to let them introduce themselves to you now. Over to Richard.
I'm Richard Burrows. I'm from Mid Wales Plumbing Heat Supplies, regular to the show, and looking forward to tonight's session.
I'm Kimbo, another regular to the show. I'm from the Heating Academy. Looking forward to the first session of the year tonight with these new guys.
Damon?
Oh, I'm Damon Blakemore. I'm an installer. That's a rubbish introduction, sorry.
I'm Mick Wall. I'm a customer of Damon's. It installed my heat pump and we monitor it, and that's why I'm here.
And Trystan, if we can hear you, you've gone all fuzzy. Ooh. Trystan, can you hear us?
Hopefully. It's not going to be much of a show without Trystan, is it?
Hello.
No.
Sorry, the connection is dropping out like crazy. Sorry, what was that? I missed that bit. Sorry.
Introduce yourself, Trystan.
Okay, I'm Trystan. I'm from Open Energy Monitor. We're running heatpumpmonitor.org, so it's like a platform for sharing. Well, it's like a league table, I guess, of heat pumps and people sharing data from their own heat pumps, including householders, but also very much installers. Deciding to put this kit in on systems in order to highlight, the quality of their installs and also just have a process of sharing learning between installers.
Great. So we'll go into all the detail about that software through the session. But I'm just going to start off by asking Damo to sort of talk a little bit around the subject of, is it enough for an installer to go into a customer's house and just fit a heat pump and set it up, walk away? Is that what else do they need to do for sort of best practice?
To be fair, yes and no. With right design, good installation, and then commission on it, and then just doing it, servicing it every year and looking after it, you know yourself that it's going to be good. But having that data there, what you can correlate and back up what you're doing, be able to see, improve if there's any things that you're dealing with. The system might be low on volume. You might find your room temperature, if it's running weather comp, and getting to where you want to be. You might find you're overshooting. There's a hell of a lot of data that helps to bring that in and just trim it. And you might see another heat pump, what someone's set up differently, where it's working a little better than what you've done, and think, I might try that on this, a different setting, whether it's using from room influence or whatnot, and it'll help you. Yeah, it helps you a long way. So there's a lot of positives from it. It's probably only one of the things that I don't actually see a negative in, and I find a lot of negatives in a lot of things. But I can only see positives about it, to be honest.
I mean, one of the key things I think, isn't it, is that if with a heat pump without monitoring, though, is quite a blind system, isn't it? Because you can get some of the data off the heat pump themselves, but ultimately, without having that platform to actually monitor, the day in, day out running of a heat pump, you're kind of, it's like a blind man without a stick, isn't it? Do you know what I mean? Kind of thing, So it's
and then I guess from your heat pumps as well aren't fully. A lot of them are just compressor efficiency. You don't like system efficiency that is really what you're wanting to do. So like your pumps, if you've got external on-off starts, you might have manifolds with pumps on, or actuators, all all that usage of electrical power adds up, and it does actually bring your cop down. For example, on 𝗵𝗲𝗁 app, it's when I took it, don't take into account the internal pump. I lost about 150% efficiency, which bugs hell out of me. But I were like sitting at like 660% on the app. But when I put the open energy monitor in and actually saw the power that it was draining from the pump, it then showed me that it were down at like 5.1. We lost like 150%. So it can give you a false security that you're running a good system when in right you might not be.
Might be able to get better efficiencies. So I don't know.
I was going to say, so I am probably the least experienced with all this high-tech kit, but there's definitely a place for it. But I know with monitoring and testing, you can sort of set your own standards and say, well, I'll just monitor this good bit and I won't monitor this bad bit. Is there a facility in your software to say, right, guys, this is the test, so that everybody does the same thing? Because in my limited knowledge of how this works, I can beat your Scott by turning down the room temperature. If we all live at 12 degrees, then I'll have a Scott of, a ridiculous Scott. So how does them? I know it's not meant to be a competition. I know it's turned into a competition, but is there a way of leveling the playing field so we can actually see, what not who's best, but who's managing to squeeze the most out of the best designs?
Yeah, I guess so. I mean, that is what's coming out of it. I mean, that interesting case of like the 12-degree house. I mean, Glenn's system on there, he was away on holiday last couple of days or last couple of weeks, and the inside temperature, it was on holiday mode, dropped down to that kind of temperature, and is getting a great cop over the last 30 days, and climbing the league table. He didn't quite get to the top. He didn't beat a house that was running at, I don't know, 20 or 21, but I think yours, Damon, still was up higher. But I mean, that data's there. That room temperature data's there, so you can drill into it to find out, what's the reason for this good performance? So you can sort of check for that kind of thing.
You have to remember as well that the difference between them is like no install's the same. As you could go next door and it'd be completely different. There's so many variables also that it needs to take into account. You got your room temperatures, you got your setbacks, are they in house longer? There's so much. So comparing you don't really compare like for like as such. It's more to what your system is, because you can change that much.
Just taking a step back, can Trystan just do an overview of what the Open Energy Monitor platform is, or the 𝗵𝗲𝗁𝗃𝗆𝗺 table is, and the equipment just around it? Because I think that's important to understand what equipment's involved in it first of all, really. So.
Yeah, good point, Richard. So on the monitoring equipment side, so to start with, on the hardware, you usually start with you have an electric meter to measure the electricity going into the.
I've got that bit. It's installed in that bit there. Look back there.
The glamorous assistant hasn't quite turned up with all the good.
I'll have to run over here, look, and do this. Right. It is actually in there. Look.
Okay. All right. Let's do this properly.
That's that bit.
So
that's that.
Electric meter. This is measuring the electricity going into the heat pump. And, sometimes you'll have multiple of these. So you might have another one on the indoor unit, another one on the immersion heater or backup heater if the heat pump's got that. And it lists what is included in the measurement on the website. So you can see for any given system, have they included, all the bits, as it were. So then the other part is a heat meter. So I should get this out the box. Oh, you got one there, yeah. Great, perfect. So that's measuring the heat output from the heat pump. It's usually located pretty close to the heat pump on the primaries. So you've got a temperature sensor on the flow, and then you've got the heat meter either on the return or on the flow, depending on the setup. But you got your two temperature sensors. You got your flow temperature, you got your return temperature, and you've got your flow rate, and the heat meter is calculating, the heat output. So now that you know your heat output and your electrical input, you can work out what the COP is. And then if you monitor over a long time, so if you monitor over the whole year, you can get your SCOP from that. So that's like a starting point. That data there's another little box which reads from those meters and then uploads that data onto the website, onto 𝗵𝗲𝗺𝗃𝗺.org. And there's a dashboard there. Yeah, that's it. So there's a dashboard there, so you can drill into your heat pump data in a lot of detail and see, like, every 10 seconds, what's your flow temperature and your return temperature and heat output and electric and so on. So that's actually just a really useful tool from a kind of, from the installer perspective, to see what's happening on the system, to work out whether the curve has been set well and that kind of thing. But also, useful if for the more enthusiast, techie householder who likes to drill into the data as well.
That's when Mick comes in.
Yeah,
so
that's
that this is a permanent fixing. This is installed when you put the heat meter. It's not like a data logger where you clip it on and fire it up through a laptop. This is something that's actually built in. Looks like the pipe work is part of it.
Yeah.
The heat meter. So this is the customer pays for this then, for this facility.
Yeah.
Is that what we do?
Yeah. And it's not it's not particularly cheap in that sense. It's it's like 600 quid or so, depending on the system. I guess a key thing that we try to do with this is make sure that we've got accurate data. So it's class 1 electric metering and class 2 heat metering. And I mean, taking a step back in terms of like the goals of Heat Pump Monitor, it was just a starting point was to try and work out what is the performance of systems that have been installed well, I guess was the big question, because we've all seen the results of like the larger heating trials, like the Energy Saving Trust and other trials where the SCOPs were like 2.8 and maybe pushing up to 3. So it was a kind of a question of like, going back a number of years, I'd worked with John Cantor, 𝗵𝗲𝗺𝗺𝗺𝗺𝗺, who's installed heat pumps for years, and helped him with some monitoring on his heat pumps. And we were seeing, often COPs around 4 and SCOPs around 4 really. So it was obvious that it was possible to get heat pumps working a lot better than these trials were showing. And then, so Heat Pump Monitor came out of let's open this out to more people and get more people monitoring heat pumps, and it's been great in particular to get people like Damon joining, because and Damon and Adam Chapman from Heat Geek, who's been really supportive. And there's quite a few folk on there like Lee and Barry from Custom Renewables as well. And there's quite a number of really well designed, good quality installations up on 𝗵𝗲𝗺𝗺𝗺𝗺org now. And what is fascinating is it's really showing what the state of the art can be. So we're just over the last 30 days in these like really cold conditions, we're seeing COPs of what's the highest on there at the moment? It's like up to around 4.9, I think, or 4.8. I think.
Can we get a screen share just so we can show people the data? Because I think that's quite important, Claire, isn't it? Just if we can, if Mick wants to share your screen, Mick, if you can do that. I think it's on present down the bottom, but. Hopefully be able to see it.
Right.
Can you see that?
Yeah, it's coming up now, Mick.
I don't know if that's big enough, but let's
Yeah, that's good.
Can you see that?
I'll let Trystan talk to what that is, and then if you need me to next slide, please just tell me what you want to poke at.
Yeah, great. So yeah, so what you've got here is you've got you've got a number of systems listed. So each row on that table is a system and a different location. So there's one there, Broxburn, West Lothian. That's renewable heat, 𝗵𝗲𝗁𝗍. That's a ground source heat pump. So you'd almost expect that to be at the top, being a ground source, but there's also there's a couple of ground sources which are much lower down on the list, so it's not always the case that the ground source gets the best. But that one is a really good system. That one's doing really well. So next down is, well, pretty much a tie position is Damon's system there with it's got the same COP over the last 30 days, and the order on this keeps changing like day to day. But anyway, the main point is there's a whole load of systems up there with COPs of, well, all of those are over 4, and we've had some pretty cold temperatures over the last few weeks, haven't we? So, this is
so it may be costing less than gas to run, which is a big
exactly
point. Yeah. In deep into winter as well, it's probably only get colder, but it's shows that if it is designed and done and installed and commissioned correctly, then there's scope there for you just straight off bat to run cheaper than gas.
Yeah, there's two things, isn't there? And that's some important information that people don't realise. Is one is obviously running a co-efficiencies of performance of 4 and above, you're cheaper than gas. Second is obviously that the grams per kilowatt hour CO2 come massively down as well, because obviously they're multiplied by the COP. So obviously electricity used is then multiplied out into heat energy that you get for free from either the ground or the air. So it's so as far as low carbon technology goes, I don't think we're really gonna beat heat pumps, are we? I don't think, but it fascinates me that the amount of people on that list. I mean, that's I don't know how many systems are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 16 odd systems on that page, and they're all above a COP of 4, that's amazing. I think, but.
And there'll be a vast range of different temperatures as well, and internal temperatures. So it's not like one spec. There'll be probably some there that are an higher flow than 45-ish. It's like I say, it's just that important to get that design right. That's where you're gonna majorly lose or gain these efficiencies.
Do you want to scroll down the page, Mick, just to show the kind of range of values? Because obviously that's the top end of systems.
So Mix is just there. You'll run 4 at the minute, won't you, Mick? I think.
Yeah, the last month I'm on. I'm there. Yeah. 4.1 in the last 30 days.
I'm down there at 3.8.
Yeah, just to say that is heating and hot water efficiency. That's because that's a really important point. Because I noticed just on a couple of the group chats when we were talking about this, a few people thought it was just heating efficiency, and it's not. That's not the case for all of them. Yeah.
Yeah. So if we carry down this list, there's 81 systems listed now, and there are some down at low 3s, but the whole point of them being on there is that they can then improve and work out what's happening. Well, there's a few octopus ones there, but it's good that they're on there, that you can look at this data and learn from it.
Yeah. One of the things I was really interested. I was going to say one of the things I was really interested in is how you Mick and Damon's actually use the data to actually improve your system and bring your COP up. So I don't know if you want to have a little bit of a discussion about that.
Yeah, we can talk to that. Yeah, I was very keen to get this from the off installed, and I was not happy to pay the £600, but I like that. I'm a nerd by trade, so I need to know how things work. So when Damon put my system in, I knew it would perform well, but I wanted the data to back that up, and I think Damon wanted it as well to back it up as well.
Well, we found IMI valves, didn't we? That
Yeah, we put some IMI valves on every radiator, and we found they were restricting flow and they weren't very good, and we swapped them out, and performance improved straight away. So you can see where you make your mistakes, and you can rectify it, and you can improve. I've made massive improvements in my hot water performance because I can see that.
Can you show some of that? Can you just click into your system just so you can show some? Because obviously this is just data. Can you just click and just show the graphing day to day?
Yeah. So.
And just explain a little bit, if either yourself or Trystan can just explain.
Yeah, I can do that. So this is yesterday. So if we hover over any point on the graph, we can see that yesterday at 9 o'clock in the morning, my flow temp was 36.7. My return was 33. Room temperature was 19.5. Outside temp was 0. And in that period there, I can highlight that period, zoom into that period. It tells me in that very sort of hour and 50 minutes in that period there, when it was -3 outside, I got a copper 3.08. So you get all the metrics. So we've got the electric in here. So it was just over 1 kilowatt. And the heat out was nearly 4 kilowatts. You've got a big summary down in this part here that gives you all the metrics for that window in view. You can look at hour, 6 hours, day, week, month. You can go back and look at any minute of any day that you have ever logged. I've got about 18 months of data on here now, so I can go back. Now we've made these performance changes, I can go back and look at how my system is performing now compared to a 0 degree day last winter, and look at the differences and how things have changed and how things have improved. And that's, in a way, that's what we've been using, myself and Damon, to make changes. Like I said about hot water, I've made a lot of changes on hot water, trying to improve that efficiency. And you can see here's a hot water run that was nearly a copper 3, which I was getting less than 2 sometimes in midwinter. But again, we've realised what's happening. We've made a change. Things have improved. And as an installer and as a customer, it's a fantastic combination that the installer can say, make this change this setting, and we should see the result change come out the other end. And sometimes it gets worse, and then you don't do that again next time. But that's learning. You only learn by making mistakes.
Yeah, Damon, if you can just discuss some of the things about mixed system that you did initially, and then how you rectified them to improve the efficiency side, because I think that's important.
All IMI eclipse valves on all radiators, but we were struggling with a couple of rooms that we just couldn't get as flow right on as correct with room temperatures. So we looked at it, and we went and we just put the because I use the high flow valves as well for the ones over 150 what needed 150 litres per hour. So then we took them out and put the flushing inserts in, and then all of a sudden we saw flow rate improve, like through the unit, and the cop went up, not much, by 0.3 or 0.4 I think, but it improved like as a unit. Radiators were feeling a lot warmer throughout. Room temperatures were better. We've got a Mixage in, so we've been playing around with this plate for 18 months. We were frustrated with Mixage, we couldn't get it working. Now we found that after everything we've tried to swap and change, that pulling it back into it. Mixed livelihood also takes into account, because you've got a full house, and when they recharge the cylinder, we found to get the best cop from hot water, we need to drain it fuller, then load it as on eco mode, so the heat pump's pulling back a little bit, which gives them more transfer across that plate. Without all this data as such, we would have never nailed this. Would have just been unhappy with Mixage. Now that Mixage is running as well as coiled cylinders in that specific time. So it's helped us get to this. It's been a while, don't get me wrong, it's 18 months, and Mick's performance has never been bad, but we've just been able to squeeze that extra out of him from what were we last year, Mick, on it this time of year, about 3.5-ish?
I think
altogether.
I had a year, when we got to the end of the first year, it was 3.6 for heating on and hot water. But we're gonna.
So now
I think we're gonna be 4+. Yeah.
Yeah. So squeeze that extra.
I can ask you on there,
so just running just above gas, you know. So now where it was equally 3.6, now at 4.1, we're running cheaper than gas if there were no other input, which is a big thing.
Yeah, it's massive. Yeah. So with the so what's the key thing? So what's been your key takeaways from this? So obviously with the flow restrictions with the heat pump, was that an electrical usage thing that caused the issues, or was it just a flow thing through the heat pump, or was it what were the sort of key things that were the hold-ups with that? And also with the plate, obviously with going into I forget was it the eco mode on the heat pump? So what does that do? So in sort of the analysis of the data, what did that do to bring the COP up?
I'll make a let you. Do you want to go? Or?
Yeah, I know the eco mode on Valence quite well now. So
yeah.
The default mode for hot water on a Valent aerotherm is normal, which just tries to throw as much heat at the cylinder as quickly as possible. The problem with that, regardless of whether you've got a coil in your cylinder or whether you've got a plate like on the Mixage, it doesn't. Neither of those can seem to absorb all that heat at once, and so the performance is not as good. You're using more electric to create all this heat that you can't actually do a great deal with. It's fast. It's just because you're throwing a lot of kilowatts at it. It does run quickly, but the performance isn't what you'd hope.
Yeah.
So on the Valent, you've got an option called Eco, which runs the compressor at about 50%. So it's a bit more of not a trickle, but it really scales back the compressor, puts the heat in a lot more slowly into the coil or the plate so that it can absorb it, and you use less electric to create that heat, so your performance improves. The only downside is that your run times are longer. So you've got this trade-off, but I'm sticking with the performance because I want to get top of the Scots, obviously. But I've done it because I wanted to prove what's possible. I like to think that this, as Trystan alluded to earlier, that the whole point of the chart is to show what a Valent with a Mixage in a 1930s semi with 4 people, normal house, what can it do? And this is what I'm trying to do. I'm saying this is what mine is capable of. That's sort of my goal and interest moving forward, is to disprove the myth and to say, yeah, 100-year-old house, it works fine.
Yeah, I think that's really important as well, Mick, because, you know, there's been a lot of negativity in the press, and, you know, a lot of installers, and, you know, they say, you know, heat pumps don't work. And actually, they haven't seen the data. I think once you show installers the data like this, and as long as they can understand what it all means, I think their takeaway from it is actually, you know what, these things actually do work. And it's not just, I mean, I've used data in the past. It's not just heat pumps it works with. It's with gas boilers as well, you know, with flow temperatures, efficiency, things like that. It works the same way, you know, and I just think it's just that level of understanding that's really important to actually bring it across to the installers. You know what, you know, you can throw them in and you can have heat pumps that run semi all right, but, you know, just with some fine tweaks or little tuney bits, or just making sure the primaries into this heating circuit are correct, and that you've calculated your flow correct, you've calculated your pressure loss across your system, you've done all that work like Damon does I know he does religiously on all his installs. It's just that putting that extra bits, you know, of work into it to actually achieve a really good performing product.
Yeah, and it's
Kimbo,
good as
you have
well.
a question?
Yeah, mine was regarding the flow rate. So something you noticed on the data you were looking at led you to think there's a restriction of flow somewhere, and presumably as a result of that, you then took out these IMI ones and you put in the flushing valves and noticed an immediate difference. So is that, and I'm not suggesting that is that because the original flow rates were incorrect, or do you think that the flow rates that it said it was doing, it wasn't doing? Because surely if you've got the right flow rate going in, which is what we try and preach about, put the right amount of energy in and you don't need room stats and all the rest of it. It seems a bit odd that by, if you like, ignoring that or overriding the maths and saying, well, we need this amount of litres per minute for that amount of energy, that by overriding it and allowing more flow rate through, you would think would put more energy into the system. So how did that work?
Well, it seems the Væland runs a lot more happier. Majority of the year they run closer to DT2 and 3. So what we were finding was when we'd setting these up, if you weren't going to go through summer and winter changing settings on them as such, when we're setting them up for DT5 and we're running differently, it was struggling. The room temperatures, I think some of the rooms were struggling to get us warm on the radiators, and they were balancing from them valves. So we just IMI tool, we just thought we'd change them out, and then we, like I said, we saw that improvement just grow. So then it made me thinking what valves are, because like I said, we size these valves properly as well. So the first one I'd done, so I went everything by the book. High flow valves over 150 litres per hour, normal valves under that. And you know what? I ain't really got the answer to question, because it's pickled my brain loads, and I can't answer it. But it just works. It works better. I thought it'd be perfect.
So do you think? I mean, I know everyone thinks there's a bit of a weird thing going on with the Valiant, and me too. I don't really. We've only done a couple, and I don't really understand what's going on. It's a bit of a head scratcher. But is that because the heat pump is working differently? Let's say, for example, you put another hit, a 𝗵𝗍𝗻 or something on. Do you think because the 𝗵𝗍𝗻 runs at 5 rather than 2 and 3, that those valves would have been fine? And also, do you think it's because the Valiant has modulation and pump modulation as well? And there's all sorts of things modulating that you can't quite get your head around. I mean, I've tried to get to the bottom of it, of how they work, because they seem to work in a slightly different way to other ones.
I think it's there's an unknown as well. It's the refrigerant side. So I don't think we fully understand how that's part in it, and keeping temperatures right at that side. I think that is the main control over what DT we're getting and how it's running. Apart from 𝗵𝗍𝗻, which is set your DT on, I've not seen any others that actually do across. The 𝗵𝗲𝗁 sits more at 2 and 3 as well, happily. And as you said before, when we've talked about this, when I understand it, we're just changing the mean water temperature as such and closing that DT rather than the pump modulating to try and keep 5. The PWM pumps, but no one can answer why they just don't modulate to keep that DT. So majority of the year, 78% of the year, mix is sitting at 2 and 3. It's not until you get into that design temperature it widens and you start hitting like your 5 DT. I mean, the 𝗵𝗲𝗁 one that I've got here is exactly the same as what the Væland thing is, and it's when it's running pure weather compensation as well. I don't know if it changed when.
Can we guys interrupt a minute? Sorry, Kimbo. Can we just show 2 different systems? So can we just show the difference between the 𝗵𝗲𝗻 system and one of the Valiants during this kind of cold snap? Because one thing I found fascinating is that you would think 2 heat pumps would work the same, wouldn't you? Do you know what I mean? And but actually, what you see is there's a lot of, what I'm trying to say to the audience is there's a lot of unknowns with a lot of installers at the moment with actually how these heat pumps are manufactured and how they're actually designed to operate. Because what I've noticed on, and this is only, like I said, thank God for the sort of data, Trystan, because otherwise you'd never see this actually going on, would you? But if you look at Damon's 𝗵𝗍𝗻 and you look at actually, I don't know, say Adam from Heat Geeks like Valiant Aerotherm, the two are totally different. I don't know if we can just have a quick look at those systems, Mick.
Well, we've got the 𝗿𝗲𝗀 here because that's my system. Mine's a 5 kilowatt 𝗿𝗲𝗀.
That's fine. Yeah. If you have a look through that, and then versus the V.
A small point to make. I mean, if we, obviously we're doing all this monitoring at the moment. I guess ideally we get to a point where, we know how a particular heat pump works. We've got the design dialed, and you're doing the same thing, and you don't necessarily need to go into all this detail the next time and the next time after that. So this is very much in a way, although it's great to monitor loads and loads of heat pumps, it's like the most value you get is at the start, with a new design, a new heat pump model. We're trying to figure out how this new heat pump model works and how best to get, how can we get the best out of it? And then hopefully further down the line, once it's more of a kind of more of a cookie cutter type approach, we know what we're doing. Yeah. It's just a formula that's being applied. Then we maybe don't need to go into so much detail, but
I guess everything's going to be different though, isn't it? Like you said at the beginning, there's so many different variables in an installation that are you going to have all of that covered with a sort of, 200 different setups? There's always going to be one that's needs monitoring to add to the list, I guess, isn't it?
Yeah. I think also like manufacturers are going to integrate this monitoring more and more over time. So, it won't be like although it'll be less work for us, obviously it'll be less of a kind of additional cost, as it were. I think as we go down the line.
Some of the important stuff though is that what we've noticed with manufacturers' data is that they are over egging their heat pump performance. You've seen that, haven't you, Damon?
Yeah, and this is where it's actually what performance is like. The 𝗲𝗲𝗺𝗲𝗺𝗲 one is just compressor performance. It doesn't take into account the internal unit. When you take the internal unit loss off that, it actually marries up with what 𝗲𝗲𝗺𝗺𝗻 is saying just for the heat pump itself. But what we're wanting a system efficiency, because at the end of the day, that's what's running your house. It doesn't matter if heat pump's running at 4 if you're losing 2 in your house, then you're only running a copper 2. It's not. We need to get this overall, and that's why I touched on it earlier, that you need to monitor every electrical input into that system, because it soon adds up. I mean, when Trystan ruined my life when he showed that I dropped 150% efficiency on it, it was like you like sit back and think, wow. It's like that's a hell of a lot just from one pump running.
And this was a COP of 6, a COP of 6.5 initially, dropping to a COP of 5, wasn't it? For like context.
Yeah. Which is just, and we had that monitoring, we had open energy on it. We wouldn't have noticed. 𝗲𝗲𝗺𝗺𝗺𝗃 didn't know about that when I asked them, so that was something like they'd learned as well. And then you see systems with buffers and pumps on manifolds, and you're talking 4 pumps. You could be talking 2.5 kilowatt of energy being used every day that's not being took into account. There's a hell of a lot there. But yeah, going on to the 𝗲𝗲𝗺𝗺𝗺𝗃 one, the main difference what I've seen is how it defrosts as such, because it's
Can you show that in the graph, Mick? Just quickly on the graph. So some of the defrost periods and the difference between the 𝗵𝗲𝗺𝗺𝗺𝗃 and the 𝗵𝗨𝗺𝗺, I kind of find quite fascinating. So.
Yeah, so the 𝗵𝗲𝗺𝗺𝗺's got a 14-litre buffer inbuilt, and it's got a 3 4-way valve. So this is something like just what 𝗲𝗲𝗺𝗺𝗺𝗃 have created, and our proper overcritical of it with the internal unit being hard to sight and whatnot. But I've been kind of made to eat my words, because I shouldn't ever question Germans, but it's coming to its own. So what it does is this buffer, it allows heating water through it, but it's not a buffering such as it's causing separation or doing anything. It's just a buffer. There's a little bypass. It fills up with normal heating water. So if you're at 30 degrees or whatever on your floor, it'll be 30 degrees in there. When it starts to preempt its defrost, it reverses the valve and it takes the defrost buffer up to 55 degrees. So you've got 14 litres of 55-degree water, which then it just recirculates around the heat pump buffer, taking nothing from the house like a normal heat pump would or a buffer and pulling that energy. Then it reverts straight back. You get a little bit of dip in flow, but then the whole process is about 7 minutes long. And then the gaps between the defrosts are quite far compared to the Valent. Looks like it does it once every hour. This is like once every 4 hours or so. So it's kind of, there's still, I think there's so much we've got to learn about the defrost cycles as well. And heat pumps, there's only so much you can do with like thermodynamics and whatnot. But big parts of the controls and how it's defrosting, that I think that's a big unknown as well, because you can see some over the winter period, the cold period, what was before, that was struggling to regain temperature after that. Like it's saying you need a minimum volume, but also minimum volumes at what temperature, how much are you needing to do that, So there's quite a lot unknowns still on defrosting cycles. Which I think. So
just a question to Trystan quickly. So what do you think is do you think, because obviously there's manufacturers give their data for different outputs. So say like at -2, +7, things like that. How close do you think from the data that you've seen from Open Energy Monitor that the manufacturers are actually, their outputs are marrying up to that performance or not?
Yeah, I think it's something we need to do more of, that kind of cross comparison. I mean, like I've done quite a lot on, because I've got an EcoDan, so I've dived into a lot to that question a lot with EcoDan, and in general it's pretty good compared to the data book. So you can select the temperature and flow temperature and outside temperature, and it'll be pretty close in terms of performance. There's always a bit of variation, but I think one of the areas that is maybe more interesting or is particularly interesting is like maximum capacity of a particular heat pump. So and there seems to be a bit more of a discrepancy here. So if you select like 2 degrees outside or -2 or and a flow temperature of 40, and then the data book will say, that heat pump has a capacity of 4.8 kilowatts, and actually you try and run it in those conditions at max output, and you might get 4.2 or 4.5 maybe. So there's like, you might be losing 10%. So on the EcoDan, I've seen like a 10%. The heat output is 10% below what the data book is saying, or that at least that's what I'm getting on mine. And then
is that because manufacturers aren't taking the defrost cycles into account properly, or is it something to do with the way they're tested in-house?
Well, I'm really interested to know why this is. So
because I've monitored a couple myself, just off the data, and it does seem that there's a bit of disparity around what manufacturers are claiming, and this isn't just with heat pumps. This is obviously, I've done some testing at Salford. We've seen, I'm used to seeing data like this, and we've seen that gas boiler performance isn't in the 93% efficiency, and it's very hard actually to get it past the 89% efficiency mark. I just wonder how much of industry, I don't know, leniency is given towards the data that the manufacturers give the installers when they're trying to actually, because with the heat geeks especially, what I've noticed is their sizing of heating systems is so very close to the actual heat loss of the property that actually there's not a lot of give if the manufacturer's data is incorrect. So I guess wondering about that,
generally the heat geek systems are availing, and they badge. Their badged output is below their maximum output, isn't it?
Yeah.
So you've got quite a different. That's completely different from, most of the other brands where the actual output during cold conditions will be below that kind of nominal output, as it were.
Are we seeing that on the data though as well? Because I've noticed a couple of systems not actually achieving internal temperature when there's defrosting going on. So I'm just wondering if maybe some of that data might have been incorrect. I don't know, because it's fascinating, isn't it? Once you start.
Yeah. I mean, another example is, we've been monitoring a Daikin system where, the data sheet says it should achieve 10.8 kilowatts at at around 0, and we couldn't get anything more than over a number of defrost cycles, we couldn't get more than 7.6, and so that's like a 30% below datasheet result. So generally, if you'll often see that daking systems are oversized to take into account this this discrepancy. So it's just one of these things, like there seems to be a lot of variation between different systems, and there's a chance that that particular system that we've been monitoring, it's just an issue with that one, and it's really difficult to prove something one way or the other. But it is a challenging thing, so I don't want to say that is definitely what all dakins do. It's just a particular example. But yeah, it would be really interesting to
typical though, isn't it?
Someone who
yeah, sorry, Tris. I was just saying it's pretty typical though. I don't disbelieve manufacturers. Obviously, we work closely with a lot of manufacturers ourselves in our business. But when we've got technology that you're trying to prove that works, manufacturers not being fully conversant with their data, shall we say, doesn't help matters with installers. Because, like for instance, say that daking unit, if that was sized as per MCS and it was sized to that kilowatt output, because the data sheets shows it is that output, then obviously that installation isn't going to be great, is it? For for homeowners like Claire, if she's getting into a heat pump, do you know what I mean? It's
Well, this was the case because we so this is my father-in-law's install, and he had a very accurate heat loss based on his previous gas use, and I suggested cutting it quite fine, and so he's missing a few kilowatts as a result.
But
that would have been, if the data sheet was right, would have been fine. Would have been but it's just an interesting one, I guess. It would be great to talk to maybe there's someone at MCS or someone at BRE or whoever's doing the kind of validation of these of things like this maximum capacity value, or a test house to just see exactly how many defrost cycles are they averaging this output over, and that kind of thing. It's difficult to do. I mean,
I'd imagine in a test house, Trystan, to be quite frank, it'd be very difficult to monitor defrost cycles accurately because most of the test houses are built inside a weather chamber, so it'd be very, very difficult to replicate real world results, that you would get out in the field in a test house. So it's kind of one of those things that. Sorry, Damon, what you saying?
They probably only tested into a buffer as well, rather than any other schematic. So they were going to have that full volume of water, whatever. They might be testing it at defrost at 55 degrees at max temp, and then pulling that through. It might just defrost fast and recover fast. They've got nothing on the other side. We like that real world living in an house, doing your hot water run and then and then doing a defrost straight after that and not being able to pick up. When it's ramped its head off. There's like I said, there's so many variables from that. A test, I've always said, a test will only show you what it wants you to show. No, I don't know anyone that's gone into a test and come out of a test and said something that they're paying to get tested and said, nah, that's rubbish, we're not doing that. They'll only show positives on it. That's what they want to get out of it. So that's why something like this highlights it for you.
I mean, I think it would be great. In a way, it'd be a great next step for Heat Pump Monitor if we could somehow partner with someone who's doing this kind of like proper test house level testing and kind of verify this data. Well, this kind of max capacity data. If there's anyone listening who knows who to talk to, who works in in a test house validating the heat, producing this kind of data output for heat pumps. That'd be great. It'd be great to talk to someone who is familiar with that side of things, because if we could connect that data, the data that's going onto the data sheet or that's going onto the MCS database with what's coming out of heat pump monitor, then that would be a really, really good connection.
Like Volkswagen scam all over again.
I was going to say, is that even being done? Is that even being done? That monitoring and sort of justifying the rating of the heat pump?
It'll be a standard test, won't it? What they'll all go through for MCS, which will just be at a certain temperature, at a certain thing, under a certain condition. That'll be it. There'll be no relay. They just be generic, just like RAS testing and stuff like that, where you just pass it as such or fail it or get it to give you. So what's interesting is when you look at something like the 𝗵𝗲𝗁𝗧 graph and you look at their 16 kilowatt, because the outputs tend to draw off between 5 and -2, where the air is, the humidity is a bit the air's wetter and more defrost, and the 𝗵𝗃 are actually quite open, and the 16 only drops off to a 12 kilowatt. So when you're sizing them as well, it's important to actually look at this information, because if you just go, I want a 16 kilowatt, that's where valence a little confusing, because people have been used to this different sizing with different manufacturers, and you get into outputs from similar units, like a 12 kilowatt valent to a 12 kilowatt 𝗵𝗃. The output on them is not 12 kilowatt at what you're wanting. They both differ to where it is. So there's loads that you actually need to know and look at to get this right. There's so many steps where you can trip yourself up with it. So it's
one question that's come in from Rhiannon, actually, who has been on sessions with us previously. Hi, Rhiannon. Who should pay for this monitoring system? A question. Does that sit with the homeowner who wants to know better about how to improve their efficiencies, Mick? Or, is it an expectation that you, as an installer, take it to the system and add it, so that at the end of the day, the client's paying for it anyway? Does everyone want it? I assume it's not legislated. Monitoring is not legislated as part of having a heat pump installation.
No.
Only when it was RHI. But now it's not RHI. There's nothing that you need to do, really. I put them on a quote as an extra and explain the benefits to them. Like you say, it can cost you quite a bit at that point. But the one on the 𝗵𝗲𝗁, EatGeek actually paid for that one to be fitted. The customer didn't pay anything for that, so they wanted to monitor that 𝗵𝗲𝗁 equipment. So, it'd be a conversation between you and your customer. If it's for you yourself to test it, then they're not bothered about it. Then down to installer, obviously, to come out of your own profit. I know Liam Barry's fitted some off his own back on his systems just to prove his efficiencies. And this is something that customers are actually looking at now. I've had a couple and said, can we get there on leak till, or can we get up there? And I'd love to be on it, and so there's a platform for you to be able to do it yourself, because the outcome from it is extra work, especially if you're getting high efficiencies from them. People are actually looking at it or interested in it. So, it could go either way.
From your point of view now, Damon, when you all you've got to do is, or same with Liam or anyone up the top of the table, is look, these are my installs. This is what I can get you, and in a way, it's like a selling point. And
that's what I said. Case study for how you can.
It proves the installer's work.
You might not be so convinced.
You're not going to be shouting from the rooftops if you're getting 𝗁𝗲𝗄 2.6, are you?
No.
Not often, no.
But then if you are getting that, you'd be looking at it and thinking, it gives you that ability to think what's going wrong here. If you're looking at it and you see your defrosting every 20 minutes and then your house is down at 17 degrees, you know that you need to do something drastic to get that. Without this, the big thing is, without this information, you don't really know what's going on there. You're taking something at face value with, are your bills all right? Or what's that onboard monitoring? This once you get into nitty gritty, what this provides, it's like I say, I can't see any negative, not one negative about having open energy monitor. Everything's just positives from that point. I can't see anything why you'd think, oh, I don't want that. You know, maybe cost, but but everything comes at a cost in life. You know, it depends what you're wanting, and it's
And it's the only way to be able to, if you're monitoring it, I guess it's the only way to really prove out and find where, like you say, Damo, it's going wrong. Why is it going wrong, and how do you then work out to make it go right?
Yeah. Well, there was one guy using it, wasn't there, on Twitter, and I think he re-insulated his pipework outside, and he changed his insulation outside was not very good, and he did some minor changes, and the improvement was massive, you know. And I think on a lot of air source heat pump installations, people underestimate how much the insulation on the external pipework matters, because if it's not done well and you've got your external pipework exposed to the elements, and you know, especially when it's like -4, -5 outside, you're going to get some severe heat transfer. Do you know what I mean? And you know, and it's little things like this, like not insulating the pipes through the walls, and just tiny little bits like that. But you can pick all that up, make changes on the system, and then reanalyze the data to see actually, well, what improvement has this made? And that's what I think the real beauty of you know, Open Energy Monitor is, you know. And that's like, next few weeks, I've run out of money this month. I said to Damon the other day, I've totally run out of money this month to spend on my own house. So next month I'll be on the old Open Energy Monitor myself, but I've got a ground source heat pump, so you know, unfairly I might be somewhere near the top, but it's certainly not through the amount of skill that Damon and a few of the other guys have put into their systems. Because you know, getting air source heat pumps running at, you know, COPs of 5 is pretty bloody good, to be quite frank. So.
Yeah, I guess like you could say, let's say you were getting a heat pump from Damon, because you've seen a couple of systems that Damon's got. You might not necessarily need monitoring on every other system. You know, the customer might be happy if the customer's not too bothered about seeing all the data. And Damon's like, well, I've done this kind of install before, then maybe it's fine just to do it without monitoring. You know, it doesn't. I think the value comes from the first few systems that you're doing of a particular brand. You know, that's where, if it's something new that you're doing, having monitoring on that is really useful. But if it's like the 10th version of exactly the same thing or something very similar, then you're not going to get so much from that.
No.
So
I was going to say, I disagree, Trystan, because I think, you know, if you think the monitoring equipment's 500 quid, the difference between a COP of 3 and a COP of 4, you know, over the term of 10 years could be pretty significant. And I think it would certainly, you know what I mean, certainly pay back that equipment in no time, especially if it's running, say it was running a COP as 2.5 versus a COP of 5, you know, there's a big monetary difference in that, isn't there? So that's my feelings on it. You know, I've done monitoring for years and years and years. I think 2005 or 6. I think I started trying to monitor systems with sensors and stuff like that. And you know what I mean? To have a platform where you're getting literally every 10 seconds updates on the system. Yeah. So literally your system's updating at 10-second intervals to give data to an open platform. I think that's really impressive. So, you know, I don't think it should be underestimated or played down. So,
customer interaction point of view as well. You're like seeing evolution of like customers, and you're like, for once you're able to, like me and Mick now, we could talk for hours about it. Sometimes the phone call was like 40-50 minutes. You know, you're getting that like level of interaction with a customer as well, which is I've never had on a gas boiler. You know, like someone which is nice, and this is all coming from them being able to look at it and think, wow, that's good, and then for them to want to improve things and try things yourself and understand them, because I think a big part of the heat pumps is that the customer's got to understand what it's doing and what you're trying to achieve from it as well. So for them to be able to see it and then think, oh, I'll try that or can't try that, and it work and not work, and see it with their own eyes is a big thing. Once it saves me call outs, I can just tell me to do it.
Rhiannon asked an interesting question in the chat about what's the manufacturer monitoring like in comparison to the heat meter setup? I've got some experience from the Valent side, and Valent comes with a nice app and gives you some COP setting, daily COP sort of graphs and stats, and I found it to be pretty accurate. It's ballpark, it's all right. 10% maybe either side. So the Valent, not bad. If you just want to rely on the Valent inbuilt monitoring, that's pretty good. I don't know about the others.
So does the Valent take into account the power? Does it take into account the power to the internal unit, Mick? The Valent?
Yeah, because the Valent is only, in essence, only has really one power input. It goes to the controller and then straight out to the outdoor unit.
Oh, so if you had a secondary pump, then that'd start showing on the Valent monitoring because that wires to the interface internally.
Yes, yeah,
it would.
Yeah,
right. All right, then. That's good.
But I don't know what like grants and Dakins, and I don't even know what you get with those and how accurate those are. So that's a challenge for a customer and an installer: is what useful information am I going to get from whatever brand I choose, and how accurate is it? And can you even trust the manufacturer data?
Yeah, it's difficult because like with the flow meters, like my Steeble's got a flow meter on it. So and that's actually I've used Home Assistant, so I've attached my Steeble through the ISG because I've got the ISG unit on my Steeble, and I can get the data off the ISG of what the Steeble's doing over the Modbus connection. But how accurate is that flow meter? You know, how well calibrated was that? What spec is it to? Do you know what I mean? You don't know, do you? And there could be a difference between units. So this is why I was keen to get the Open Energy Monitor, the actual equipment, and get the software up and running on my own system, so I can actually see, because my system at the moment showing that I'm running a 𝗻𝗃𝗃, right? But I'm like, is that right or is that not right? And that for me, I'm like, well, so what? It was 700 quid because I've gone for that because mine's the bigger heat pump, gone for the bigger heat meter, which is the sort of the cost in the actual equipment is sort of the heat meter. So, I'm like, it's worth it for me because I'm like, there's not many ground source on that data either. So, I thought it's just important as well from my perspective to put my unit on there, show everyone actually what's possible in a new build. Because, there's not many new builds on there. The majority of those properties are retrofits, aren't they? Or older buildings, which, but show you what the performance can be on a new build property and what that looks like. So it's just interesting to do that, isn't it?
What about calibration? Did it need calibrating like annually or biannually, the flow meters, or is that just it? You just fit it and that's it?
As I understand it, yeah, just that's it. Yeah, with the yeah.
There's been a few posts on the Open Energy Monitor forum about some meters getting clogged up. But maybe that just sort of like anything that can get clogged up in the system, I suppose.
Water quality in it again. You're going to have issues if water's not right.
One of our future sessions will be on that again, I think, when we Claire.
Yes, I think we will. Well, guys, it's been so interesting. Honestly, I was completely blind to this whole subject. Obviously, don't have a heat pump, don't make heat pumps. So I think it's been really interesting, and we've had quite a lot of people on tonight, actually. And so hopefully they've all found it really interesting. If anybody's watching in the future on demand, post your questions in the chat, and I'll find out an answer for you, or one of the guys who's probably on the group will probably answer it for you. Anything you want to know. I think there's links. Mick, you've put up links to Open Energy Monitor, haven't you?
Yeah, I've put some links into the
So if anybody's interested, go check out the website, ask us any questions that you want on the feed here, and I'll find out the answers and come back to you. Thanks, guys, so much for your time tonight, and I will look forward to learning more from you all and seeing you again sometime in the future on other subjects.
Thanks for having us, Claire.
Thank you.
Thanks, everyone. Bye.
Bye, everyone.